So if you remember Carlos and Clarita, they're opening a pet vacation place for owners to go out of town. They can send their pets. So we have cat pens that require 6 feet of space, while dog runs require 24 feet of space, and they have up to 360 square feet available in their short storage shed for pens and runs. They also figured up a startup cost equation, so Carlos and Clarita plan to invest all of the $1,280 they earned from their last business to venture to purchase cat pens and dog runs. It costs $32 for each cat pen and $64 for each dog run. Now, we set up our equations a couple days ago where we had 6x plus 24y equals 360, and then the equation that represented the amount of money was 32x plus 64y equals 1280. Remember, x represented cat pens, where y represented dog pens. So I want us to graph both of these equations. If we notice, it says scale your x by 4 and your y by 2. So when I get ready to do this, remember you still need to label what each axis represents. So my y was dog pens, and it said to scale my y-axis by 2, so I'm going to go up by 2s. And then my x was cat pens, and they said to scale that by 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. From this point, you just want to take the two equations and turn them into your slope-intercept form, and then graph the two lines at the same time. So I'll let you do that on your own, and you can refer to the picture that is posted in Google Classroom of how to do that. At this point, they want us to turn the cost equation into an inequality that represents them not spending all of their money. So the cost equation was 32x plus 64y equals 1280. We turn it into an inequality, and then they don't want to spend all their money. So we will have 32x plus 64y needs to be less than 1280. Remember, just less than, we don't want to make it equal to, because if you make it equal to, they will spend all their money. Then they want us to turn the space equation into them not using all of their space. So their space equation was 6x plus 24y equals 360. We don't want them to use all their space, so it'll be 6x plus 24y is less than 360. Then it tells us to go back to the graph and shade the areas that satisfy each of these inequalities. Remember, both of these will be less than, so we're going to shade below each line that you've graphed. Again, you can refer to the image that's on Google Classroom under the notes. So Carlos remembers his father suggesting that boarding the same number of each, perhaps 13 cats and 13 dogs, would be possible. So is this truly a possibility? Well, remember, we can plug it in for both the space and the cost equation. So 6 times 13 plus 24 times 13. And we will need to know if that is less than 360. That's my space equation. So I'm just going to go straight to the calculator and type this in. 6 times 13 plus 24 times 13. And we get 390. So right away, we know that 390 is not less than 360. So this is not possible. I could also just refer to my graph and see if 13 is in my shaded region, and we can see that it is not. So if we don't use our graph suggests the number of possible cats and dogs they could board, well, this is where we're going to have to use our different methods, whether we want to use our elimination method or a substitution method, that is completely up to you. But you want to be able to find the total amount. And again, you can refer to the image that is in Google Classroom to see the work. So we solve systems of inequalities. This is when we have two different inequalities graphed on the same plane. And just like for a system of equations, we were looking for the intersection point of the two lines. We're still looking for the intersection point, but we're looking for the intersection point of the whole set. So step one is to graph each inequality on the same graph, then shade the appropriate area for both, and then the solution is where the shaded regions intersect. So let's look at the first example. Y is greater than 2x minus 2. I'm going to scroll down so we can actually graph this. So we start at negative 2, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And come back to my y-intercept and go down 2 to the left 1. Okay, notice it's greater than, so it's going to be a dotted line. I'm going to wait to shade until I get finished graphing just so it'll be easier to read the graph. Now for the second equation, I must put it in slope-intercept form. So I get negative y is less than or equal to 2x plus 6. I must divide everything by negative 1. Remember, when I divide by a negative, I must flip my sign. So negative 2x minus 6. My y-intercept is negative 6. We go down to the right 1. When I run out of space, I'm going to go up 2 to the left 1. You can see an intersection point of my two lines here. I'm just going to keep going until I run out of graph. And this is now greater than or equal to, so it is going to be a solid line. Now I need to go back to my shades. So for the first line, it was greater than 2x minus 2. It's going to be everything that is on top of the line here. Notice I'm using different colors. It does help track items. And then greater than negative 2x minus 6. So that's going to be on top of your line. This area, remember, you can always test and check. Plug in 0, 0 to see. And it is true that 0, 0 is a part of the solution. So when I get ready to find my complete solution, it is everything that's going to be in this yellow space. Remember, this blue dotted line is not included, but the red line, because it's solid, is included. So anything that is in this yellow area will be a solution. So 0, 0 does fall right in the middle. So yes, that is the solution. For the next examples, you see that we have to put both of these in slope-intercept form. So I have negative y is greater than negative 2x plus 3. Divide everything by negative 1. So y, I have to flip my sign, is now less than 2x minus 3. So negative 3, up 2 to the right 1. Or I can come back to my y-intercept and go down 2 to the left 1. It is just less than, so it will be a dotted line. And then when we solve the next equation, again, it's got to be in slope-intercept. So the y is less than negative 4x plus 5. Positive 5, moving down 4 to the right 1. Then I'm around space, so I can go up 4 to the left 1. Again, it is also just less than, so it has to be dotted line. Less than means below. You could test the points if you wanted to, 0, 0, to see where to shade. And as I'm getting ready to graph the other one, you need to go back. Y is less than 2x minus 3. And so if it is less than, we know it needs to be below the line. You could test your points is 0 less than negative 3, and that is not true. So I have to say it on the other side of 0, 0. So my answer set here would not include the dotted lines, but everything between the two. So is the point 1, negative 3 part of the solution? There's 1, negative 1, negative 2, negative 3. So yes, it is. For our next example, we must get it in y-intercept again. So we've got to subtract x from each side. Negative y is less than or equal to negative x minus 2. Divide by negative 1. So y, flip my sign, greater than or equal to x plus 2. Start at positive 2, and then it's up 1 over 1. So the end of the graph. And down 1 to the left 1. Toward the end of the graph. We notice that it is equal to, so we do want to connect with a solid line. The next one, we need to subtract x from each side, so we get negative y is greater than negative x plus 2. Divide everything by negative 1, which means I flip my sign, so y is less than x minus 2. Same slope, so you can notice that our lines are parallel, which means we're going to have some kind of unique answer here. It is just less than, so it remains a dotted line. Less than means we shade below. And then we go back and check the first one, which was greater than or equal to. So we have that solid line and greater than. Greater than means we shade above. So here, we have the solution set. Notice there is no intersection point, so there will be no solution. For the last one here, y is greater than negative 2, so I come to negative 2. It's just greater than, so it's going to be a dotted line. Then we have x is less than or equal to positive 1. It's a solid line, x equals 1. Okay. Less than 1, so 0 would be an answer choice there. And then y is greater than negative 2, so that would be on top of our line here, which means my solution set would be everything in this yellow area. So when they ask name 3 points that are a solution to the set, we just want to pick values that are in that yellow space. So negative 2, 0. Negative 5, 6. You could say negative 1, negative 1. So any 3 things that